I did a video looking at rotational kinetic energy, specifically rolling an object down a hill. This is one of the two major cases where you start looking to use rotational energy to solve a problem. So this is going to be rotational kinetic energy for unwinding a spool. Let's say I have a big spool like this, and we're going to give this thing a mass of 10 kilograms. We're going to call it a solid cylinder, so a half. We'll give it a radius of 20 centimeters. I'm going to hang from this a mass. We'll give this one a mass of 4 kilograms. And if it starts some height above the ground, let's go 5 meters above the ground, I would like to know the speed when this block strikes the ground. So find the impact speed. I'm going to do this again with energy. So I'm going to have my initial energy, and I'm going to have my final energy. And now I have a system that is made of a block and a spool, and this thing is, here's my axis, and I'm stuck in place. The spool's not going to fall. Here we go. Initially, my potential energy, I'm going to have an mgh from the block. In the end, that block's going to hit the ground, so nothing. Initially, the system starts from rest. I didn't write that, but start from rest. So I have no kinetic energy of any kind. In the end, my block is moving, so I'm going to have a half m v squared, and my pulley, or my spool, is rotating, so I'm going to have a half I omega squared. One thing that I really need to be able to solve this problem is this. This block meets my spool out here at a radius of r. Or I guess it's the full radius of the wheel, at a radius of r. What that gives me is a linear speed that's equal to r times omega. With that, I'm going to plug in here as omega is v over r. And that's going to give me one equation with, or that's going to give me an equation with just kind of the one unknown. So I start with an energy of mgh, and I end, I've got a half m v squared, and I also have a half moment of inertia of the wheel times v over r squared. mgh, get a half m v squared plus a half moment of inertia, that is a gamma mr squared. I'm going to get a v squared divided by an r squared, and my r squareds can go away. This r squared thing going away will pretty much always be the case, except if this wheel, or if this hanging mass, this is a spool, so it could be that the outer lip of the spool comes out farther and that this is connected in here. If that were the case, then the R, the capital R, would be different from the point of attachment R. And they wouldn't be able to cancel. I would just have to keep them both. Not a big deal. MGH equals, I've got a half in every term, and I've got a V squared in every term. What I'm left with, I've got mass in the front term, and then I've got a gamma capital M. This is a lowercase mass, and then I've got a gamma capital M in the other term. I'm solving for V. V equals, I'm going to get a 2 mgh. I'm going to divide by the mass of the block plus gamma times the mass of the wheel, all under a square root. And now I can start plugging in numbers. 2 times 4 kilograms, 10 meters per second squared, 5 meters. And on the bottom, I get 4 kilograms plus a half times 10 kilograms, all under a square root. 2 times 4 is 8, times 5 is 40, times 10 is 400 on top. And that is kilogram meter per second squared is a newton times a meter. And on the bottom, I get 4 plus half of 10, so 9. 400 over 9 is 44.4, and when I take the square root of that, I get 6.7 meters per second. If this thing had just fallen instead, this term would have been 0, because my wheel isn't rotating. This term would have been 0, and I would have had 400 over 4, which is 100. Take the square root of that, and I would have gotten 10 meters per second. So I am slowed down quite a bit, really, because some of my energy budget, remember, left side of this thing is like my energy budget. Instead of being able to put all of it into straight line falling motion, I had to put some of it into the rotation of the wheel. So instead of 10 meters per second, if I just cut the rope, I am now going 6.7 meters per second because the wheel is turning too.